Well, welcome back. This is the fifth round of me going through the challenges in my book, The C Sharp Player's Guide. And this time I'm going to be jumping ahead a little bit to get to our first boss battle, the Hunting the Manticore challenge at the end of part one. If you've been doing all of the challenges in this book, some parts of this are going to feel familiar because it actually builds on some things that we would have done in the prototype and the magic cannon. I haven't done videos for those two yet, so we haven't seen that on video, but I think you'll get the gist as we go through it. So with that, let's just dive in to the challenge. I'll leave that up. And I'm gonna come in here. I'm gonna make a new project for this. I'm gonna choose a new console app, not the .NET Framework one. And I'm going to give this a name, Hunting the Manticore, if I could spell it right. Next, choose my framework. I want .NET 6. And I'm going to delete this code that's here to start with. We don't need that, but I am going to pull over some stuff out of the book. I like having this checklist as I'm working through these challenges. So I've got this. These are straight out of the book. I'm going to delete these notes. I don't need these notes other than just to kind of reiterate what they say. This is a big challenge. It's going to take a while to get through it. And so definitely expect this to take some time. Don't feel bad if it takes you quite a bit of time, and don't feel bad if it takes you perhaps a bit more time than it takes me in this video. And then this one, use methods to focus on solving one problem at a time. We're going to put methods to good use here. They are a very useful tool. So we'll make sure to do that. And then this version requires 2 players. So this challenge really, it's technically a 2-player game because you need somebody to pick. You need somebody to pick the distance that the Manticore is from the city. But that's all that player 1 will do. So it really would be better if a computer could just randomly pick the location. We don't have the tools to do that yet, so we'll just make a different player pick the number, and we can come back to that and make the computer pick it. It isn't that hard to do, but we don't need to do it right now. So we'll defer on that until later. So let's get started writing some code. We can generally, with these objectives, we can usually work top down, and we can kind of solve them one at a time. So we'll start here. Establish the game's starting state. The Manticore begins with 10 health points and the city with 15. I'm going to kind of lump this one in with it because I think it's very similar. The game starts at round 1. So these to me, all of these are clearly storing state, and it changes over time. So that means we probably need a variable for all 3 of those things. And I'm gonna use int just because they're a good default. They make a lot of sense unless you have a compelling reason to go bigger and use a long. They're a good choice unless space is tight and you need to use a short or a byte. And yeah, so they're just the kind of the most obvious natural default tool, and I don't think we have a compelling reason to use anything else here. If you choose something else, like honestly any of the integer types would work here. None of them will cause the code to be wrong. So any integer type would be fine. You could use a floating point type, but everything we're doing here is all integers. We're never dealing fractional damage, so uh, I'm going to use an int. So let's see. Manticore health is 10 to start, and the city health is 15 to start. And the game starts at round 1. So we can check that one off and that one off. And now we're ready for this third one. Ask the first player to choose the Manticore's distance from the city. This is between 0 to 100, and clear the screen afterward. Now I'm going to snag the description that is in the book. The description, the objectives listed here do not require you to use any specific, like that we if we look in the book, it gives us an example, but this is a way it could look. Don't feel like you have to stick to this exactly. You can do whatever you want to do here. But I'm going to stick to it pretty closely. So I'm going to grab this text. So we do console.writeLine and put in player one, how far from the city do you want to station the Manticore? Let's see. A couple of things I want to tweak here. I don't want that 32 in there because that's the input. And then also I want to use write instead of WriteLine. It's such a habit to just use WriteLine, but we don't need it. In this case, we actually want the input to be on that same line. So using write allows us to get the input on the exact same line. So I'm going to do console. So now we want to actually get the input, and we're going to want to store that in a variable as well. So I'm going to declare a variable here for that distance. So we'll do console.readLine, but we'll also we need to convert what comes out of that, convert it to an int. So convert.to int32. There. So that will take the input and convert it to an int. This is something we've done, but at this point in the book, we've done these types of things a whole lot. This is very familiar at this point. So I think we can check that one off now. Run the game in a loop until either the Manticore's or city's health reaches 0. So loop. We could probably use any of the loop types, but to me this sounds like a while loop. Leave the condition blank for a second. Okay. It was only a second. Now I'm ready to fill that in. So what we want to do is we want to loop until either the city's health is 0 or the Manticore's health is 0. So we just need to come up with a condition for that. So while city health is greater than 0 and Manticore health is greater than 0. So as soon as one of their healths drops down to or below 0, then we want this to end. If either of these become false, then because of the and, we'll drop out of the loop. So while city health is greater than 0 and Manticore health is greater than 0. So while both things survive, keep looping. Before the second player's turn, display the round number, the city's health, and the Manticore's health. So we've got, the first thing, I'm going to pull over a little more of this. We got 3 lines here. I got 3 lines here, one of which I think we only want to display one. So we can just do console.writeLine and just grab this here. Oh, you know what? We forgot this. Clear the screen afterward. Otherwise, player 2 is going to be able to see. So let's just put that in right here. Console.clear. And now these other two, so we can do console.writeLine. And console.writeLine for this last thing. These 2 lines, however, we want to happen every time through the loop. So I'm going to move them down here inside of the loop. And like right now, this will always say round 1, city 15 of 15, Manticore 10 of 10. We want to use our variables for these things. So we're going to do string interpolation. That's the simplest way to do this. And we're just going to come in here, put a $sign there so we can do string interpolation, and then replace those fixed values with our variables in curly braces. Okay. Before the second player's turn, display the round number of the city's health and the Manticore's health. So I think we've checked that one off too. I think we've gone long enough. We ought to run this and see where we're at. Let's make sure to sanity check and make sure that everything is proceeding as we expected. How far from the city do you want to station the Manticore? So I'm going to enter 32, let's say. So that's mostly what I expected. We're in this loop, and we're never changing the city's health or the Manticore's health or the round number for that matter. We're not changing any of these values. So we're just going to get the same thing over and over again. The loop will never, since the city's health is never going to drop down to 0 and the Manticore's health is not going to drop down to 0. We're never going to, the condition will never be false, and we will keep, it'll always be true, and we'll keep looping over and over and over again as fast as possible. So far so good, but obviously we're not done yet, and I'm just going to have to close this. I do want to say, though, that we should use some methods. In particular, I feel like this thing seems like most of it seems like a good method to have. So I'm going to come down here and I'm going to say not public. Sorry, I'm getting ahead of myself there. It's just int prompt for number. We're going to have this method take a message, and we're going to do basically all of this except just going to say in here, return the result. And then here we're going to get rid of this, and just call that method. So kind of stitching things together here. Hold on. So now we have a method that we could ask. We could ask any question and get a number as a result. That method is pretty reusable, and I think we will reuse it here in a second when we get to get a target range. So given that we need to get another number from player 2, we'll be able to reuse this method, which is one of the main reasons to use methods in the first place. It isn't the only reason. It can be a good idea to make methods for things that aren't being reused. But yeah. So the other thing I want to say here, because this is a thing that I see a lot of new programmers make mistakes on, and it has to do with how this method is defined. This method so the main method, actually, like our entry point, is actually this entire thing from here all the way down. Which means this method is defined inside of another method, our main method. We don't see that like a specific definition for that main method because the compiler makes it for us. If we were using the old style, of I'm actually gonna do this. If we're using the old style of programs, we would actually do something like class program. Like we would have to write all this stuff out. Public static void main string array args, and then we'd put this stuff in it. And now it's a lot easier to see that this thing actually does live inside of main. However, most people in the old style actually wouldn't put it there. They'd put it after main. And then you got to slap this static on, which you could do anyway. Anyway, so like in this case now, it's specifically defined outside of main, but what we've got is the equivalent of this. So prompt for number, these methods that we define are inside of the main method, even if we don't show that. Now, the reason that's important is things that are inside of other things can usually access other things inside of their parent. By that I mean, in here, we could actually do something like this. This method doesn't have its own city health variable. It is just reaching out to the outer world and getting the city health from the main method. Now, there's a time and a place for that. That's called, well, it's you would say that this method has captured the city health variable. It's also called a closure. That's actually like there's a time and a place for that, but it isn't most of the time. Like you are often better off having methods that their only communication with the outside world is the parameters they're given and the return value. And the reason for that is that it's a lot easier to like reason about what that method does because you don't have to look anywhere else to see what it might be doing. Oh, and the other big thing is you know that when you call the method, there's no like weird things that are going to happen as a result. If, for example, we did something like, let's suppose we did something like, let's say we started this at 0 and then this down in here did something like round number plus plus to get it to be round number 1. Now, here when I say prompt for a number, then I do that. But if down in here I did something like prompt for number, hey, player 2, what do you want to do? Now, in this case, if I run this, you'll see, in fact, let me run this really quick. Hey, player 2, what do you want to do? So it says we're on round 1, and I'm going to say 50. Interesting. Where's this 15 coming from? Oh yeah, that's from this city health. Okay, I was confusing myself for a second there. Like normally we would think, well, hey, every time we through this loop, we want to do round number plus plus, so we want to move on to the next round. And now, I'm just gonna start this over. Now, because we incremented to. Okay, now let me try this again. So now I put in 50, and now we jump all the way to round 3, and we don't like it's not obvious why it did that, and that's because by calling that method, we get these weird side effects because this is like reaching out to other data that we weren't necessarily expecting it to do. It just basically what ends up happening when it's doing that is you get kind of this like spaghetti of code where everything's all kind of intertwined and entangled, and you just like you never know what method is going to have some weird side effect that you weren't expecting. So as a general rule, if it's possible to not reach out to other things and just use parameters and return values, If you can do that, that's usually better code. It's called a pure method because it doesn't have any side effects. Now, technically speaking, there is a side effect here. We are changing the text that's displayed on in the console window. So technically we actually do have some side effects here, but they're side effects that we were explicitly expecting, and they're pretty minimal. It doesn't affect the state of the program other than just what the user sees in front of them. So I think that's a side effect that we're willing to tolerate. But I do see a lot of people who will just put in here, they'll just have this code directly access these variables and especially change their values. And again, that can be the right thing sometimes, but in a lot of cases that's not what you want. So all right. Anyway, so with that aside, like I said, I'm going to, in general, prefer methods that all the data is given to it by parameters, and all of the results are done by return values, and that's worth considering, I think, for sure. So I've kind of, with that whole discussion, I've kind of jumped ahead of myself here. So we want to see, let's see, because we're actually just about done with this one. So maybe we should just do it. Do this one. So get the target range from the second player and resolve its effect. So we're already doing that here. I just have a weird. I want to change the text on it. Enter the desired can range. Yeah, that's what the book has in it. So, and I don't want to use number here. I want to use target range, a better variable name. So I think that actually does check off this. And actually, because now we've got this in here, round number plus plus, we actually can also check off that. So let's see, let's come back to here. So compute how much damage the cannon will deal this round. Now there's some complicated logic here. To me, this feels like something that very definitely could use a method for. So I'm just gonna write this as a method. I'm gonna stub it out. So int compute expected damage. And I'm just going to say return 1 for, return 1 for a second. And I'm going to come up here and I'm going to say int expected damage equals compute expected damage. All right. So we've got a method, it always returns 1. And we can also put in this text that's supposed to be in here. The can's expected to deal expected damage this round. So if we run this now, we're actually getting pretty close to a complete game. So the cannon is expected to deal 1 damage, enter the desired range. So now the player 2 can enter in a value. And well, I'll fix that in a second, but we are starting at round 0 and we need to start at round 1. Enter the desired cannon range. So now we've got a cycle going on, and player 2 is asked to pick a value, which we can do. And so we're actually pretty close here to a working game. We just have a few missing pieces. And so, okay, so now we gotta turn this logic into code. So if it's a multiple of 3 and 5, then it's 10 points of damage. If it's not a multiple of both, but if it's still a multiple of 3 or 5, then it's 3 damage. And if it's a multiple, and it's 1 in all other cases. So we've actually got that last case here. In order for this method to make a decision, we need the round number. Now this goes back to the conversation just a minute ago about whether we should about if it like we could just use the round number in here. That wouldn't, I see a lot of people do that. It's not bad. And where you're reading a value, like reading data out of them versus modifying them, it still tends to be like pretty reasonable. So we could do if, well, let's do this. So it it makes sense to know if something's a multiple of 3 or a multiple of 5. So let's do this. Let's make some variables for whether it's a multiple of 5. So bool is multiple of 5. Now we need some sort of Boolean expression that'll tell us if it is. And the way to do that is if the round number, and then with the remainder operator. So the mod operator, I keep calling it the mod operator. Technically in C#, this is called the remainder operator. And there is a difference between the two, and the difference applies only to negative numbers. For positive numbers, it all comes out the same. And a lot of programmers, even if they know that distinction between remainder operators and mod operators or modulo operators, will still just say mod. So a lot of programmers, even though this is technically a remainder operator, would still say round number mod 5 for this. But yeah, so let me take a step back. The reason why we're using this is because this gives us the remainder after a division by 5. If the round number is 5 and we divide it out 5 ways, we will have no remainder. The remainder will be 0. If we have 10 and we divide it out, among 5 things, everybody would get 2, and there's no remainder. So things that are multiples of 5, the remainder ends up being 0. On the other hand, pick a different number like 6. 6, if we divide that out among 5 people, everybody gets 1, and there's 1 left over. So the remainder is 1. So in that case, so if it's not a multiple of 5, then this little expression here will end up being some other number besides 0. So if it's a multiple of 5, it will always be 0 after using this mod or remainder operator. So, and that is one of those things that, like, it takes some time to kind of wrap your brain around at first if you're not familiar with it, but it is a really common idiom in the programming world. This is like this expression, is it a multiple of 5? Is it a multiple of 3? Is it a multiple of 2? To do the remainder or mod operator and check that against 0 to see if it is a multiple of that number. So this is this is how in many programming languages you would do something like, is this thing a multiple of 5? That's all that's doing here. And then I'm going to duplicate this line and change this to 3 because we also want to do that. So now we have a variable that tells us if we got a multiple of 5 and one that tells us if we've got a multiple of 3. And now the rest of our logic should be pretty simple. So if it's a multiple of 3 and 5, then we deal 10 damage. So if is multiple of 5 and is multiple of 3, return 10. Else if is multiple of 5, return, what was it, 3? I think it was 3. Let me just double check. 3 if it's a multiple of 3 or 5, and 3. All right, so if it's a multiple of 5 and a multiple of 3, return 10. If it's a multiple, else if it's a multiple of 5, return 3. Else if it's a multiple of 3, return 3. There's a couple of little things I want to, that this code works, and I think we're there. I don't think we need to do anything else. I think we can check this off now. But I do want to, so normally, like, we only want this to go into one of these paths. So it makes sense to use if, else, if, else, if, else. However, if we do go into one of these, we're going to immediately return. So, strictly speaking, I can remove all those else's. And I think that just makes the code simpler, shorter. And it still does the same thing. Now, the other thing we could do is I don't have any particular problems with this, but we could also write this way, or if is multiple of 5 or is multiple of 3, and then get rid of this line. This code here, this condition, ends up being more complicated. However, the problem description was written in that same way, so I do kind of like that it mirrors the challenge description. Now, yeah, so the other thing that I want to mention here is I said earlier that it's usually best if a method can just be used without having to directly access variables. We are using round number here, and if we passed in round number, so if we made a new parameter here, and I'm gonna, for the moment, I'm just gonna call this round to make it very clear that this is a different variable than this one. Now this method isn't grabbing variables from the containing method, which I do like in the general case. Like one thing that this allows us to this also just got a lot more reusable, because now we could do something like this, which we couldn't do before. We could do something like this: console compute expected damage round number plus 1 next round. So I like the flexibility that gives us. In fact, let's run this and just make sure that it still looks like it's doing a reasonable thing here. Oh, the cannon is expected to deal 10 damage this round. The cannon is expected to deal 1 damage next round. So I think this code is correct, other than we do need to start at round 1, not round 0. We should go fix that. But yeah, so like I said, this method, because it doesn't tie itself directly to these variables that are here, it's also more flexible. So if your code happened to have a method that just pulled from these other variables in the main method, that, like I said, there's nothing specifically bad about it. It has a tendency to be more rigid, less flexible. And so I avoid it unless there's some very specific reason why I'm intentionally going out of my way to do it that way. And that isn't usually the case, but like I said, there's plenty of situations where it does make sense. Now, we don't need to keep this in here, so I'm going to delete it. And I'm also, while I'm thinking of, I'm going to make the round number 1. And I checked this off, but we're not that far along yet. We did get the target range. We just haven't resolved its effect. So we need to do two there's kind of 2 sub parts to this. Well, 3, because there's get the range. The other 2 parts are tell the user if they overshot, fell short, or hit the Manticore. And if it was a hit, reduce the Manticore's health by the expected amount. I'm going to deal with that second part first, because to me that's a little bit easier, which is a good strategy in general. If you have a very big problem and you don't know where to begin, sometimes it makes sense to just find the easiest thing in all of that and just start working on that. In most situations, that will allow you to kind of start wrapping your mind around the whole problem one little chunk at a time, and you can show momentum and you feel better because, hey, I'm making progress, I'm getting things done, and in general you can still rework things that you've already written. Anyway, so that's the focus right now. Is if it was a hit, reduce the Manticore's health by the expected amount. And the good news is we already have that amount here. So all we need to do here is say if target range. So if we had a hit, if the target range equals the distance to the city, then Manticore health minus equals expected damage. Remember, minus equals is shorthand for this. This just takes its existing value, subtracts so it retrieves the current value in there. Say it's 10 to start. Subtracts the expected damage, might be 1. So we compute that and we get 9, and then we store that back into here. But minus equals is a shorter way to do the exact same thing. So now in this case, we should be reducing the Manticore's health if we deal damage. And so now the only thing we need to do is tell the user if they overshot, undershot, or whatever. So I'm going to come in here and do if target range equals distance to city. I'm separating these on purpose a little bit. These are separate like stages in my mind. So even though I already have a statement here, we'll talk about that more in a second, but I'm intentionally going to say, so if target range equals distance to city, then what we want to say is this. Console.write line. That round was a direct hit. If target range is less than distance to city, let's see. So if the target, if where we were shooting at is less than the distance, and that means we are short, we fell short. So in that case, this is the text that we want. That round fell short of the target. And then if it's greater than the distance to the city, then we want this text. That round overshot. All right. So there we go. This to me, because it feels like its own little separate task, I think we could put that in a method as well. And we could do display attack result. Just come down here and make a void method. It doesn't need to return anything. Put these here. So in order for this method to do its job, it needs access to two variables, the target range and the distance to the city. And I think, again, I want to just pass in both of those. So we'll pass in target range and we'll pass in the distance to the city. That means we've got to put our variables here. So int target, int actual. I'm trying to get the white space and things to line up. So I'm just trying to figure out where to put a space, but something like that. All right. So now we display the attack result. The one thing I do want to say here, I mean, I mentioned this earlier, like I intentionally picked a different variable name here. But if I use the same one, actually, what is that? What was it? Distance to city. If I declare a parameter here with the same name as something in an outer scope, something from a container like the main method here, then this supersedes that. This is referring to this, not to this now. And the way this is set up, we actually lose our, like this totally hides This one, we have no way to get back to it. And we're okay with that. We don't, at this point, we don't need to be able to reach back over to that. We've got all the information we need right here. So we don't have to pick a different name. They can be the same name. I want my white space back. I just like, maybe it's OCD. I like having all these line up here and these line up here. Okay, so I think at this point now we can finally check that off. And we are just about done here. So if Manticore is still alive, reduce the city's health by 1. That should be pretty easy. If Manticore health is greater than 0, city health minus minus. That retrieves the value in that variable, subtracts 1 from it, and then updates the variable with that new value. So I think we are done there. When the Manticore city's health reaches 0, end the game and display the outcome. So, and we are there. So at this point, when the game is over, we will break out of this loop and the game will be over, but we haven't displayed the outcome. So at the end of this loop here, we can do that. Except we only want to do this if the Manticore's health is actually I'm going to intentionally introduce a bug here. All right, so a couple of things. Now this will always, so if the Manticore's health is equal to 0, the Manticore's been destroyed. We haven't handled the alternative scenario, which we should do. Else console.writeLine. The book doesn't show an example of what text to display here, so we're just going to invent it. The city of Consolus has been destroyed. The uncoded ones forces have defeated you. Something like that. So the problem we have here is we can deal damage in not like it doesn't always just go down by 1. So there is a scenario here where the Manticore's health will go down, from 10 to 9 to 8 to 5 to 4 to 3 to -7. And if that happens, then this is not true. And we will get this. So even though we destroyed it, its health is now -7. It's going to tell us that we lost, even though we won. So we could, a couple of options here. One, we could just say, well, we're going to allow that. We're going to allow it to go negative. It's fine for it to be negative. So if it's less than or equal to 0, then we know it's dead. If it ended up -7, it's still dead. The alternative would be we could keep that 0 and we could come up here, and where we do subtract this, we could, for example, we could say, we could clamp the amount of damage we do such that it doesn't allow the health to go below 0. Or we could put in an if statement here that says if the health is less than 0, then don't let it go below, like set it to 0. So if this assigned Manticore health to -7, we're just going to then turn around and set it back up to 0 so it doesn't ever drop below 0. So all of those are possibilities. I'm going to stick with this version for now. I think it works well enough for what we're doing, but none of those other options are bad either. And let's see. So I think we can check off this one, and let's run this. So let's see. Enter the cannon range 50. That round overshot the target, which it is because it was 32, and I'm going to do 25. It should be short. Notice the city's health is coming down, as we'd expect. The round number's going up. And now we're going to put in 32. So this should be a hit. And the city's health dropped as well, but so did the Manticore's health. So everything seems to be working right now. And now we found out we just keep going. And this should finish it off. And we got our happy message. Maybe we should run that again one more time just to make sure that we can actually lose the game. Okay. Yes. All right. So last thing, it's a pretty minor thing. Use different colors for different types of messages. So obviously we can use console.foreground color to change the color of things. But rather than go into every single place where we do a console.WriteLine and add in a console.foreground color, I'm going to get clever here and I'm going to make another method, void display right colored. I'll just call it colored right line. Colored right line. And we're going to pass in a string. And we're going to pass in a console color. Then I'm going to do console dot foreground color equals color. A console dot right line the text. Now everywhere I can replace console.WriteLine with colored right line and then just add in, like, so this is the failure message. So maybe we do console color.red. Right here we can do colored right line and do console color.green. That's our victory message. I'll deal with this prompt for number in a second. I think I want it's okay, I think, for this to be gray. And I think I'll say the same thing about this one as well. We'll maybe change this to be a different color. Something that'll stand out. Maybe we make it white. And let's see. So I think the only thing we have to deal with now is, oh, these. Let's deal with these. So I'm going to make these the kind of the result be magenta, except if it's a hit. Oh, let's do normal. So we'll do normal magenta for a direct hit and dark magenta for these ones that are short and over. And then this is the last thing. And I could call colored right line, though we do want right, not right line. So we could make a colored right that calls right here instead. But given this is the only place where this is used, maybe I'll just do console.foreground color equals console color.yellow. So let's change the question text to yellow, and then here we'll change the input color to cyan. And now we can run that and it should have a lot more color. Player 1, so we got our yellow. How far away from the city do you want to station the Manticore? 32. And we get our cyan here. Enter the desired cannon range, 50. So it gives us this magenta, overshot the target, 25. Fell short. We get our 32 in here. That was a direct hit. 32, 32, 32. We get the green text when we win. And let's just run this again with should get the red text right here. Okay. So I'm happy with those colors. And we did end up making 4 different methods. Some of the like we could consider putting some of this stuff into other methods, though. I mean this seems like a potential candidate for another method. Maybe some of this stuff is a potential candidate for a method. This like we're gonna tell the user all the status of things. I could imagine somebody having an is game over method that captures that logic. There's other things in here we could make methods. I don't think I feel too bad about where this is. I don't know that we need more methods for the sake of more methods. I do like the collection of methods that we do have here. And it looks like we've checked off all the boxes on all the different things. So I think at this point we're done here. So this is definitely a harder challenge than any of the other ones. I think we're about 50 minutes into this, but this is a solution to it. Again, your solution is almost for sure going to be different. There were 1,000 little decisions that we made while going through this, and you're going to differ from me on some of them, and different does not mean worse. It just means different, and that's totally normal. So how many lines of code is this? So a 78 line program. That includes this stuff up here. We could maybe get rid of this now. So 64 lines. This, like I said, for a single program, this is the biggest one that we've made. But anyway, I'm pretty happy with where that's at. And I don't think there's any other specific things I want to talk about. So I think we can be done here. So thanks again for joining me, and I will see you next time.